Hello and welcome to today's VMware webcast. Before we get started, there are a couple of housekeeping items that I would like to go over. First, we want to make this session as interactive as possible and encourage you to ask questions at any time using the question and answer box located to the left of the slides window. You can also use the question and answer box to get technical assistance if you should need it. The tabs located in the question and answer box are where you can find additional information about today's presentation. Today's presentation features streaming audio only, so there is no need to dial into a teleconference. You'll need to make sure that your computer speakers are turned up in order to hear the presenter and today's content. You can also fine-tune the audio by using the volume controls inside the media window. This presentation console allows you to interact and customize the layout to fit your viewing needs. You can collapse and expand any window on the console just like you would on your desktop by dragging the corners in or out. In addition, you can also maximize or close any of the windows on your screen by clicking the corresponding icon in the upper right-hand corner of each of the windows. At any time, you can reset the console to the default layout and access additional presentation functionality using the widgets at the bottom of your screen. Now, I'd like to turn things over to today's presenter to get things started.
Hello, everyone. This is Rajiv Thakur joining from VMware, and I have a co-speaker, Eric Shanks, with me. We're really excited to talk about how to get started with Kubernetes workloads, and we'll do a quick introduction and then get right into it. So my role is product marketing for modern applications on VMware Cloud. And today I'm going to sort of talk about how different customers are facing challenges around deploying modern workloads, either on premises or in the cloud infrastructure. And, depending on where you are in the journey, I'm going to talk about sort of how to get from step A to step B and really get started with deploying Kubernetes-based workloads.
And I'm Eric Shanks. I'm a senior technical marketing architect from VMware. Focusing on VMware Cloud on AWS and modern apps. And today I'll be giving you an overview of some of the Tanzu Kubernetes Grid architecture, along with how Tanzu Mission Control works. And we'll go over a demo of how you can use Tanzu Kubernetes Grid with Tanzu Mission Control on VMware Cloud on AWS.
Thank you, Eric. So with that, let's get started. So, obviously, the topic of app modernization has, been a priority for, not only infrastructure teams, but also app development teams and really organizations, right? And according to some surveys that are being done by leading analysts, a lot of the companies today, whether they're a small, medium, or large enterprise, are really using Kubernetes-based platforms for container orchestrations, right? So in general, the lead technology to orchestrate containers is Kubernetes, and it's being widely adopted. So that's one trend that's, leading us to have this conversation here today. What's also important to note that these container deployments are happening, on-premise and in the cloud, right? They were initially all cloud-native deployments, but they've also started to, happen in the data center now. And obviously VMware strategy, I'll cover that shortly, but wanted to sort of make sure that these data points are surfaced before we have that conversation. There's another trend that talks about, over the next 5 years, what percentage of organizations will be running containerized apps in production. And as you can see, this trend from 2019 to 2025 is just accelerating, right? Organizations were at 35% or fewer in terms of how many orgs were deploying containerized apps into production. And the expectation in the market is that there will be at least 85% organization deploying production apps that are containerized by 2025. So certainly a big priority. And then this priority is not just happening at the customer side, but it's also happening in the software ecosystem where ISVs are delivering their software in a container format, right? And there's a lot of benefits to sort of why containers. are important and key, and to bring newer customer experiences to the market, to bring better employee experiences within the organization, and really to create that new mobile virtual AR, VR, or AI-driven experience that all organizations are innovating on, right? These are sort of initiatives that all fit under the app modernization use case, and we're going to sort of deep dive into that into this presentation today. But wanted to sort of share why this is important across the board in every industry, right? There's pretty much no company on the planet today that can think about innovating without sort of figuring out how to modernize applications or build newer modern applications, right? So that's what I wanted to start with. So with that, let's shift the topic to, what challenges both development teams and infrastructure teams face, while dealing with app modernization or kicking off these projects, right? So on one hand, developers are being, tasked with building these newer modern applications, right, that are mobile friendly, they're web friendly, or they're available to bring newer experiences to the market. In general, that drives a lot of cost of public cloud services that are being consumed by these organizations, and also an investment is needed in modern infrastructure platforms to provide the developer teams with the tools they need and the underlying infrastructure that they need, for which there's also potentially a need to hire a DevOps organization and sort of set that up for both day zero and day two operations to deliver modern application building tools to developers, right? And the infrastructure teams that run mission critical apps for enterprises, are in another silo, right? And hence there are these multiple operating models for your applications now in your organization. And, what this does is these sort of problems combined, increase the time to market to build newer applications. When you look at things like standardizing your application footprint across the board, making sure it's highly secure, making sure that everything is protected and also most modern in terms of its capabilities, is always a challenge that both developer functions or infrastructure teams or operations functions deal with. And the common goal is always to sort of get to market sooner with a new app, right? So these are some of the high-level challenges that these personas face. So having talked about the challenges that both the personas face, I'm going to now talk about what VMware Cloud on AWS is and how it addresses some of these challenges, right? And over the past, 4+ years, VMware Cloud on AWS has been, sort of the preferred cloud service for vSphere-based workloads to migrate them from on-premise infrastructure to AWS global infrastructure. And, because VMware Cloud and AWS is based on, VMware Cloud Foundation at the back end, it consists of, the full stack hybrid cloud infrastructure, right? Based on vSphere, vSAN, and NSX to allow customers to migrate applications to the cloud. And when these workloads are migrated to the cloud, customers could use the myriad of AWS services to actually modernize these workloads. And today we're going to talk about, how customers can get started with VMware Cloud on AWS and VMware Tanzu standard to do some of these modernizations easily through the VMware stack as well. And Eric will obviously show some demos and details around the technical implementations, whereas I'll cover some of the benefits of why these two offerings, VMware Cloud on AWS and Tanzu Standard, are better together. Okay, but in general, if you step back, what does VMware Cloud on AWS deliver? Besides the easier path to sort of cloud migration, it also allows you to have a fully managed infrastructure as a service, right? And something that allows bidirectional portability, for workloads between the cloud and on-premises infrastructure for various use cases, right? Potentially even allowing customers to get sort of the advantage of the global AWS outreach and have a new location spun up to add some capacity in a different geography, but also sort of allow you to make sure that there's on-demand access to capacity and allowing really the VI admin or the IT admin, as we like to call them at VMware, to essentially perform cloud migration and then potentially help the developer teams do app modernization once these workloads are in the cloud. And then what we'll also cover today is how do VMware Cloud and AWS customers get access to Tanzu Mission Control to centralize some of these multi-cloud cluster management capabilities, which are unlocked by and through VMware Tanzu standard. So with that, let me shift the focus to sort of the use cases that customers have deployed VMware Cloud and AWS for primarily. And this is really aligned with a long-term cloud strategy that a lot of the customers have when they choose VMware Cloud and AWS. So, next-gen apps is one big use case. We'll talk about that in depth today. But some of the other use cases, the ones that have been more prominent in the past, have been performing cloud migrations, doing data center extension, doing remote virtual desktops to bring a lot of the underlying use cases like desktop bursting or disaster protection, or even delivering desktops as a service to your employees are things that the virtual desktop use case unfolds. And then disaster recovery is also a very strategic use case for our customers, right? Where they need a new DR site, or they want to replace an existing DR site, or really complement an existing DR implementation through a new global footprint that AWS unlocks. VMware Cloud and AWS allows you to do all of these use cases, right? And the ones that, like I said, we'll deep dive today into will be the next gen apps, right? Because we provide customers a path to not only modernize applications to and through AWS native services, but also sort of build new apps and modernize hybrid apps using VMware's Tanzu standard stack. And so we'll talk about that briefly today as well. So first of all, VMware Tanzu standard is supported on VMware Cloud and AWS. You can consume a VMware Tanzu standard, purchase that package. If you already have a VMware Cloud and AWS license, then you can combine them together and just get started with your modernization journey. So the two solution components that you need are essentially a VMware Tanzu standard license, and then obviously a VMware Cloud and AWS license, so that you have some infrastructure to deploy Kubernetes applications on. And what this unlocks together is the ability to do enterprise-grade Kubernetes for multi-cloud deployments with a global control plane and a consistent and secure management at scale. So what we're really bringing to market as a differentiation is not a point solution, so you can sort of build modern apps and build containers and use Kubernetes to orchestrate them. What we're really bringing here is the ability to deploy on an enterprise-ready architecture, where you have upstream compliant Kubernetes clusters that are managed through the Tanzu stack, and specifically through Tanzu Mission Control if you're a platform operator or an SRE, and operate them consistently across the board, right? And make sure that there's enhanced governance and security that these applications need to meet some of the challenges we talked about earlier that customers face today with app modernization around bringing applications that are containerized to production, right? We want to make sure that when you put an app that is containerized into production, it's highly secure, it's enterprise grade, it has the ability to assign policies to it, and there's governance and constant observability, not just for one type of cluster, but for multiple types of clusters, because we recognize that you may choose a specific Kubernetes distro from a native cloud provider, or use VMware's Tanzu Kubernetes Grid clusters to standardize these Kubernetes footprints across the board. But we want to give customers the choice to use other Kubernetes footprints as well, and manage them centrally through Tanzu Mission Control. So first of all, we're giving you the choice to deploy Tanzu standard as VMware on any cloud infrastructure. What that means is if you have an on-prem deployment, then you can use, vSphere or VCF, whether you prefer a compute stack or a full infrastructure stack to deploy Kubernetes. Like that's your control point and choice point for the infrastructure that hosts modern apps and allows you to perform enterprise-grade Kubernetes on-premise. If you're wanting to do away with the business of managing this infrastructure and you want a fully managed infrastructure, right, to deploy your modern apps on, then you would choose something like VMware Cloud on AWS, or potentially our other cloud partnerships that will support Tanzu Standard going forward, right? So we will essentially provide Tanzu Standard as VMware on all the infrastructure choices possible. Obviously, today we're going to talk about how VMware Tanzu Standard and VMware Cloud on AWS are better together. But I did want to sort of share when we step back and look at how Tanzu Standard is offered to customers. It is a fully flexible deployment model for literally your infrastructure choice that you can make, and change at a later stage. All right. So with that, let me deep dive a little bit into, what the mission control offering does, right? And so, a lot of our customers deal with the problem where there are multiple developer teams. Some of them may be on a specific cloud provider's Kubernetes distribution, right? And some of them may be on another one, right? So you could have a dev team that's using GKE, or you could have a dev team using Amazon's EKS, right? Or the other Kubernetes distributions. What Tanzu Mission Control provides is the ability to actually perform a standard Kubernetes policy implementation that is, secure, provides governance, allows you to, do global control plane because of its policy engine that can be applied across all of these multi-cloud Kubernetes deployments. So you bring sort of some sanity to this day two operations as an SRE or a platform operator through Tanzu Mission Control. And this is the kind of architecture you want to put in place if you really want to be ready to scale these Kubernetes workloads, right? And bring these containerized applications into production. And that's kind of the path we would recommend to customers going forward. So we talked about VMware Cloud on AWS, its benefits as a hybrid cloud ready infrastructure as a service. We talked about VMware Tanzu Standard and what it does. Let me switch the conversation to how this solution comes together and talk about the joint benefits of VMware Cloud on AWS and Tanzu Standard on this slide. So no matter where you are in the journey for modern applications, whether you've already begun deploying modern apps on these multiple Kubernetes distributions, or if you are thinking about doing app modernization and you want that first step, or if you're very far ahead and rolling out applications in production, we have a solution for you, which is the combined benefits of VMware Cloud on AWS and Tanzu Standard to have a infrastructure that is hybrid cloud ready and VMware managed, because of VMware Cloud on AWS's infrastructure as a service model. And then with Tanzu Mission Control, which is part of Tanzu Standard, your platform operators can actually now have a global control plane for all the Kubernetes deployments through multiple developer teams, right? And centralize all of those platform operations. Bring that enterprise-grade consistency that you need, and security and governance and policy management that you need across the board. And then essentially what you're now able to do is have all of these personas, right? DevOps teams, IT admins, and developers innovate jointly on the same platform that's fully enterprise-grade ready, scalable, and ready to be delivered in a hybrid manner, and really meet you where you are in your journey, right? So that's what I wanted to sort of have you guys understand before Eric goes into specifically what the Tanzu Kubernetes Grid is and demos its capabilities, as well as demo Tanzu Mission Control. So with that, I'll hand it over to my co-speaker, Eric Shanks. The floor is yours.
Thanks, Rajiv. And one of the things I wanted to do before we actually got into a demo was kind of describe some of the concepts of like the architecture on how these two products work. Tanzu Kubernetes Grid, we'll start with it, and then Tanzu Mission Control after that. And then once we've got a feel for how these components are supposed to work together, then we'll go into the demo and show you how you can actually deploy them on VMware Cloud on AWS. So to start, let's start with Tanzu Kubernetes Grid. One of the things that happened when we started building Kubernetes clusters was there was this indecision about how customers were going to start using it. Were customers going to be building a few large Kubernetes clusters and deploying all their apps to it, and maybe sharing it across teams? Or were they going to be building a bunch of smaller Kubernetes clusters and then handing those out to individual teams or use them for individual environments or apps or something like that? And what we ended up finding out is most customers are using a whole bunch of smaller Kubernetes clusters and kind of using them as a boundary for, say, multi-tenancy or blast radius or something like that. When that happened, we had a new architecture for how Kubernetes clusters get deployed. Tanzu Kubernetes Grid uses Cluster API to do a lot of the orchestration in the background. And what really happens is we first deploy a Tanzu Kubernetes Grid management cluster. And then from the management cluster, we're able to apply desired state policies to the management cluster. The brains inside the management cluster will then read that desired state and take whatever actions are necessary to make those desired states possible. Usually those desired states in this case are deploying additional Kubernetes workload clusters or child clusters so that you can actually run your apps on. So in a general deployment, you may deploy one management cluster, and then from there you would have manifests to deploy multiple workload clusters where your apps will actually live, and you may assign some of these clusters to specific teams or a specific app or a specific environment. So the way we do this is through the Tanzu Kubernetes Grid CLI on your workstation. So this is your laptop or a jump host or your CI/CD servers. The first thing that happens when we're trying to create our management cluster is we create a local Kubernetes cluster on the workstation. So if this is your laptop, we'll deploy a Kubernetes cluster in Docker containers using a product called Kind. And Kind stands for Kubernetes in Docker. And it's got the cluster API components in it. Now, we've got an engine in there running, and eventually this will deploy a management cluster into whatever cloud provider we're trying to deploy it to. In this case, it would be VMware Cloud on AWS. So the local Kubernetes cluster builds a management Kubernetes cluster for us. And then once it's done, we move those cluster API components into the management cluster. This process is typically called a pivot. And then once we've got the management cluster up and running and the cluster API components there, we'll remove that temporary Kind cluster that's on your local workstation, and further commands will be sent directly to the management cluster. And these will be those YAML manifests that are describing what clusters we want to build. And then from the management cluster, they'll go out and deploy those clusters for us. So you're going to see this in the demo. Then you may be asking, well, what does a cluster manifest look like? It's very similar to any other Kubernetes manifest, right? They're going to be written in YAML. They've got a specific API version and a kind. You're going to give them metadata, things like the cluster's name. And then you're going to have characteristics about the cluster that you're going to be deploying, right? So I can decide how many control plane nodes I want. I can decide the size of my nodes. I can decide my storage classes. I can decide my worker nodes. I can decide what version of Kubernetes I want to actually deploy. And then we can deploy these YAML manifests to that management cluster in Kubernetes. And then if we needed to, we could also go and do other things like edit these manifests after they've been deployed. So you could do, you can create clusters, obviously. You can also then scale out clusters by just going in and modifying the number of count for worker nodes. You can update the version just by updating this YAML manifest and reapplying it. So that's kind of the way that you operate with Tanzu Kubernetes clusters. You're gonna be using Kubernetes concepts to build additional Kubernetes clusters. Now, the second component I wanted to talk about is Tanzu Mission Control. And Rajiv did a great job of talking about the global control plane that Tanzu Mission Control is. Tanzu Mission Control is a SaaS application, and we're going to be using it to communicate with additional Kubernetes clusters. So if we've deployed Tanzu Kubernetes clusters with a management cluster, those can be attached to Tanzu Mission Control. And then Tanzu Mission Control can actually take over policy management and lifecycle management of those clusters. So in this diagram on the slide, you can see we've got two big blue boxes here that are labeled with local control plane, or TKG management. Those are those management clusters that we were talking about earlier. And then those management clusters have additional Tanzu Kubernetes clusters underneath of them that they have deployed or they're managing. TMC would be able to link up with both of those and assign policies to all of those clusters, and then they can use the local control plane component to deploy additional clusters or scale them or delete them or whatever you might need to do. But you've got one console to manage all of your clusters. Now, on the right-hand side, you might also notice that there's a couple of other clusters that are not TKG clusters. This is an OpenShift cluster and an Amazon EKS cluster, just as examples. And those can also be attached to Tanzu Mission Control, and we can assign policies to those clusters as well. Now, you might be asking, well, what kind of policies are we talking about? A really common example I'd like to use is from this slide. I've got 3 different Kubernetes clusters in this slide. I've got a Tanzu Kubernetes cluster, an OpenShift cluster, and an open source Kubernetes cluster maybe I deployed with Ansible or something. All 3 of those clusters could be in your environment. They could be used by different teams. But you can see I've got configuration differences between each cluster. It makes it very hard for an operations team to manage these clusters because they're all different. We would call these Snowflake clusters. What typically we would like to see done in an enterprise is we've got some sort of standardization across all of those clusters, and we're applying the same configurations. So instead of using different image registries for each cluster and having a different set of role-based access controls, we can attach these clusters to Tanzu Mission Control, and then Tanzu Mission Control can push down policies the way that we want them, so that maybe they're identical across clusters, so every cluster looks the same. Or maybe you've got some subtle differences with like role-based access control, but everyone's using the same image registry. They all have the same pod security policies assigned, things like that. So this is one of the big benefits to Tanzu Mission Control. Another benefit for Tanzu Mission Control is what the platform operations team or maybe the developers even actually can use TMC for. In this case, I've still got those same 3 clusters. And in this case, I've got deployments from 2 different teams across all those clusters. So this isn't really that uncommon either. Maybe you've got 2 development teams working on 2 different products. They're sharing the same Kubernetes cluster because they're sharing resources or something. But one of the teams wants to be able to see their workloads across all the clusters in the environment. Tanzu Mission Control can help us with this. Once those are attached to TMC, the namespace belonging to Team 1 can be grouped together in what we call a workspace in TMC. And then Team 1 would be able to look at just their workloads across all the clusters and not see Team 2's workloads. And so this is a great way for you to kind of divvy up your infrastructure and show it to the platform operators or developers who care about those containers. The way TMC works from a hierarchy standpoint, we've got cluster groups and we've got workspaces. Cluster groups, easily enough to understand, it's a group of clusters. Workspaces are groups of namespaces. So you've got Kubernetes namespaces and you're all assigned to one, you have quotas and things. You can have multiple namespaces as part of the Tanzu Mission Control workspace. And then the way that these are grouped together, we can then use these groupings to assign policies. So I could assign policies by namespace, or I could assign policies by a workspace, which includes multiple namespaces. I could assign policies to a cluster, or I can group clusters together and say production clusters or development clusters and assign different policies based on what environment they're in. So TMC gives us a lot of ways that we can divvy up how those are grouped together and then how we assign policies to them. And then lastly, before we jump into the demo, I wanted to just mention that deploying a Kubernetes cluster is not the end of our work. Just like like deploying a virtual machine, it's not ready for production until we've got it attached to backups, attached to a monitoring system. We've got some sort of disaster recovery in place for that VM. Those things aren't ready until all of those other pieces are together. Kubernetes clusters are very similar in that regard. So once we've got a Kubernetes cluster deployed, we also need to think about, well, how are we getting logging done for that cluster? How are we doing ingress for applications that are running on that cluster? How do we get performance metrics that are running on that cluster to see if our cluster needs more resources? There's a lot of other things that we might want to attach to those clusters. And these are all combined as Tanzu Kubernetes Grid extensions. So if you've got Tanzu Standard, you've already got the ability to deploy Fluent Bit for log forwarding to whatever your log aggregation tool is. You can use Contour for your ingress routing into the cluster, and Prometheus and Grafana for visualizing your performance metrics, right? So we have a lot of these options. I want to make sure that we don't stop at the Kubernetes cluster because there are additional things that we need for day 2. And with that, hopefully you've got a good understanding of the architecture and what the components actually are. And let's step into a demo. Deploy Tanzu Kubernetes Grid's first management cluster, I want to mention that I have done some of the prerequisite work for us already. There are a few things that need to be done before you can deploy TKG on VMware Cloud on AWS. The first one I'll mention is firewall rules. So I've already gone into the VMC console and I have created firewall rules for both the compute gateway and our management gateway. So if you're not familiar with VMware Cloud on AWS, there's a compute gateway that is used for all of your resources that you're going to deploy in vSphere. There's also a management gateway that protects things like NSX and vCenter. I have already created the firewall rules to allow us to access vCenter from our Kubernetes clusters, as well as basically one Kubernetes cluster talking to another Kubernetes cluster. If you're looking for where these firewall rules can be found, we have a TechZone article that explains how all of these firewall rules work and what you need to be adding. You can add these by hand by following the guide. There's also a script at the end that you can go download, fill in your information, and then deploy TKG after you've deployed the firewall rules. The other piece that I've already done is also to deploy an NSX Advanced Load Balancer. So if we want to have our applications be load balanced so that we can withstand a node failure, we also want to make sure that we've got a single endpoint that's not going to change. For us to send our traffic to before it gets to our Kubernetes cluster, we'll need some sort of a load balancer, and the NSX Advanced Load Balancer is a perfect tool for this. So I've already deployed this. I've already set it up with a username and password. It's got an SSL certificate that we're going to be using. This is already deployed in our VMware Cloud and AWS environment. Okay, now that that's out of the way, now we can go ahead and start with the deployment of our management cluster for TKG. So this starts from the command line, but and it can continue all the way through it from the command line. But the first time we're going to deploy a management cluster, it's really helpful for us to actually go and grab, put in some information in a UI of some sort. And I'll show you that now. So we do Tanzu management cluster create --UI. This will pull up a UI where we can enter our information. And the first thing that TKG's installer asks us is where we're going to deploy our management cluster. TKG is our multi-cloud product, so you can deploy this on vSphere or Amazon or Azure. You'll have to pick which one. Depending on which one you pick, you'll get different questions, and you'll kind of see why we're asking different questions there. For VMware Cloud and AWS, we'll be selecting vSphere. Okay, so you're going to have to fill in some information here. This is going to be information regarding your IaaS platform. So it needs to know how to talk to vCenter essentially here. And we'll fill in a server, username, password, and then we should hit connect. We'll verify that the thumbprint is valid for our vCenter. And then, since this is a version 7 or later version of vSphere, it's going to prompt us whether or not we actually want to create a management cluster or not. vSphere 7 has the opportunity to use vSphere with Tanzu. We're not going to do that in this case. We're going to actually go ahead and deploy a management cluster. But there's another product that you can use the Tanzu CLI with, and it's trying to ask you whether or not you want to do that or not. So we're going to go ahead and continue with the management cluster. We'll put in an SSH public key. This public key will be created on any of the virtual machines used for our Kubernetes cluster, so that later on we can go and access those nodes if we have to for troubleshooting purposes, or we're changing something on the local host machine. The next set of questions asks us whether or not we want a development or a production cluster. A development cluster has a single control plane node. It's going to be a smaller cluster. It also means it's a single point of failure. If we selected a production cluster, we're going to get 3 control plane nodes, and those 3 control plane nodes will be using kubevip to make sure that we can access a single IP address, and that IP address will be on one of the active working control plane nodes. This is recommended highly for a production environment. Since this is a lab, it doesn't really matter. I guess I'll pick the production one here, and I'll select medium as the size. So your control plane nodes are going to have some sort of a size associated with them, and you can pick small, medium, large kind of thing for that. I'm just going to pick medium for this. Under management cluster name, we're just going to give it a name, and I've selected HT Management Prod. We'll have to have a control plane endpoint, and this is the IP address that we're going to use to access our Kubernetes cluster. So anytime I if I look at my kubeconfig file after this is deployed, it's going to be connecting to 10.130.10.12. Machine health checks is a way for us to determine whether or not the machines themselves are healthy. So if a machine health check fails for any reason in our cluster, TKG is going to then delete that node and create a new node to replace it. It'll put it under the same load balancing and everything, but the machine health check is determining whether or not we do that. The worker node instance type, same thing. You get kind of a small, medium, large, extra large type thing here. I'm just going to select medium, but this is for our worker nodes, which is actually where your pods and containers would typically run. This is not what's managing the cluster. This is where your workloads run. On the next screen, it's an optional screen, but this is to connect our TKG cluster with the NSX Advanced Load Balancer. So this is one of those tools that I had already created ahead of time, deployed the load balancer. This is the IP address for our controller for the load balancer, a username, a password, and a certificate. And hopefully all this stuff is accurate. And if I hit verify credentials, it does a connection to the NSX Advanced Load Balancer. And the rest of the stuff we can just pick from a drop-down. Then we can click Next. The next screen is another optional screen. We can put metadata about our cluster here. Any additional labels or tags or anything we want to put on that, we can do that. On the resources screen, we're going to have to start putting in some information about where we want our virtual machines to live in our vSphere environment. So the first thing is I got to select a VM folder, and I've got a folder already created called TKG. I have to tell it what data store I want those virtual machines to have their disks on. So I'll select one of the data stores in my vCenter. For the clusters, hosts, and resource pools, we got to determine whether or not we're going to put this under the cluster resources. I'm going to select my compute resource pool, so my virtual machines will live there. Under the networking settings, I have to select what port group, essentially they're attached to. In VMware Cloud on AWS, this is called a network segment. So I'm selecting my Tanzu network segment here. You can also change the IP addresses for the cluster service CIDR or the pod CIDR. You don't really need to. Typically, these CIDRs will work even if you're deploying multiple clusters. They can reuse those CIDRs. You may not want to reuse these CIDRs if you're using any of these IP addresses, say like on-prem or in your VMware Cloud and AWS environment, could cause an overlap and some weird network issues. If you're in an environment that's not allowed to access, say, the internet by default, you have the option of enabling proxy settings. So you can enter your web proxy information here, and as the virtual machines get created, they'll have the settings already built to use your internal web proxies. That's not the case in our environment, so I'm going to go ahead and skip that and click Next. Another optional step is specifying an identity management solution. So as these clusters get stood up, they're all using local role-based access controls. You can enable identity management, and you can connect those clusters to either an OIDC provider or connect it directly to LDAP. You fill in this information, and it'll start using any of the users that are listed there, and you can log into those Kubernetes clusters as those users. I'm going to skip over that for this example. Then one other prerequisite I should have mentioned earlier, the OS image. So these are virtual machine templates that are already created in your vCenter environment. They're specific to the version of Kubernetes that you're going to be deploying. I'm going to be deploying version 1.20, 1.20.5 specifically, and you can deploy either a Photon or an Ubuntu image at this point. I've got both of the templates installed, so I could select either one of those. I'm going to use Ubuntu for this example. And then we click Next. On the next screen, this is an optional step, but one that we highly recommend. You can automatically configure your Tanzu Kubernetes clusters to be registered with Tanzu Mission Control. Tanzu Mission Control is going to let us do policy enforcement and lifecycle management of our Tanzu Kubernetes clusters. It'll also let us do policy enforcement of clusters that are just upstream conformant, and that could be things like EKS or AKS. We can still enforce policies there. So I've already got a registration URL, and I'll put that in the URL link and hit the Get YAML button. And this will go out and grab the YAML from this URL and populate it here for us. And then once it's populated, we can continue. This just means it's going to automatically register for us. The last step here is you can determine whether or not you want to participate in the Customer Experience Improvement Program. This gives us some data about how the clusters are built so that we can help improve the product later on. It's up to you. And then last, you could hit Review Configuration, and it's going to show you all the settings that you've already previously configured. I would say this would be a great place for you to just copy these down, but even better, at the bottom we have the CLI command equivalent. So remember initially I had pulled up the CLI and I ran Tanzu Management Cluster Create -- UI, and it started this web browser for us. We could have done the same thing with a Tanzu Management Cluster Create -- file and then passed it the YAML file that would have been created. Since we did this through the UI is actually going to create this YAML file for us and then run this command. I'm going to copy this because that's a good thing to keep track of, and I can go reuse this YAML file later on. If I wanted to repeat this demo without using the UI, all I'd have to do is run this command and it would just stand up my cluster. So it's really good for repeatability. The next step would be for me to hit Deploy Management Cluster. I'm not going to hit Deploy Management Cluster because that's going to take some time to actually spin up the VMs from template and deploy those and install the Kubernetes bits and get all that stuff working. And I don't think we want to spend time with that today, so I've already built a management cluster for us. So if I go back to the CLI, I'm going to cancel this, clear the screen. And then from here, I've already deployed our management cluster, but the next step for me would typically be, how do I log into that management cluster? So I can run Tanzu Management Cluster kubeconfig get, and then say -- admin. And this is going to get a kubeconfig file that's giving us permissions to access the cluster. And it'll put it in our list of contexts. So now we can access the cluster by running this command, which I'll run right now. My context is switched, and now if I did a kubectl get nodes, you'll see we've got 3 control plane nodes and 1 worker node listed here, and we're ready to go. The next step is typically to deploy workload clusters for whoever's going to actually be deploying Kubernetes services, pods, containers, all that stuff. Now, we can do that directly from the command line. I could do something like Tanzu cluster create, and then say file, and then I could pass it one of those config files. Now, if I look at the existing config file, this is the file we used for the management cluster. You could go in and change these names here to whatever you want, and then just run the Tanzu cluster create command, and it'll go build our child clusters, or our workload clusters, depending on what you want to call them. In this case, I'm not going to do that. Clear the screen. Let's get rid of this. And we'll get rid of this. Now, if we look in Tanzu Mission Control, I want to look at a few other things that we could have done, and some other things that we can do still. First, if we look under administration and we look at the management clusters, you can see we've got 1 cluster listed already. That's the management cluster that we created through the Tanzu CLI, which we ended up using that UI, right? But when we registered it, it registered it as a management cluster. From there, what you can do once you have a management cluster registered is you can go into your clusters list, and you can see I've got 3 of them already deployed. But I can go in here and do create cluster. I can select the management cluster that is going to build our workload clusters. And then I can walk through a similar deployment process here as we did through the UI. The first thing I have to select is a provisioner, which equates to a namespace that's in our management cluster. I don't have any namespaces created. I'm not organizing my clusters that way. So I'm just using the default. You can give the cluster a name, of course. And then you put it into a cluster group. Cluster groups we're going to talk about in a little bit, but a cluster group essentially is a way for you to organize clusters together. Then you can also add labels and descriptions. You're going to have to configure some information about what cloud it's being deployed on. It already knows it's a vSphere environment, so it's going to be asking you for data center. So you have to select your data center from the drop-down, what Kubernetes version that you're going to be deploying. You'll have to put in your SSH public key again, and then you're going to be selecting your networks to deploy the cluster on. And again, you can change the pod and service siders like we did before. We'll again have to pick a resource pool, a virtual machine folder, and the data store where those virtual machines are going to live and the disks are going to reside. And then another familiar screen where you're going to be saying, well, whether you want a single control plane node or 3 control plane nodes for either high availability or smaller clusters. And of course, a control plane endpoint, which is how we're going to access these clusters. And then on the last screen, you'd add the node pools, which are your worker nodes. So you could set this to 3 or 10 or whatever you wanted to set that to, and change the instance size. The default pools, you're going to be able to create additional pools, so that you could maybe say, I'm using these set of worker nodes for a specific application or a specific function, and maybe I'll have a different pool for something else. But then you can hit create cluster, and it will create the cluster for you all through the TMC UI. Now, in our case, I'm not going to do that again because it's just going to waste time while we're waiting for things to provision. I have already created 3 clusters here that we can use for some additional demos. Now, up until this point, we really haven't done anything other than deploy our Kubernetes clusters and get them registered with Mission Control. We're not really doing much with them besides that. Mission Control is going to allow us to do some pretty powerful things across not only a single cluster, but across a fleet of clusters. So one of the things that we look at first is when we deploy these clusters, we put them as part of a cluster group. And you can see over here on the right side, some of these clusters are in the development group and some of them are in the production group. If we look at cluster groups, you'll be able to see those listed here as well and create new cluster groups. The cluster grouping is really a way for us to just group objects together because we can then later on apply policies to them. So I'll show you that in just a little bit. But cluster groups is essentially just a way for us to group our Kubernetes clusters together so that we can assign policy. A workspace is a way for us to consolidate the workloads that are deployed on our Kubernetes clusters so that we can view them through Tanzu Mission Control. So here I've created a workspace called the Loyalty Workspace. And a workspace goes across clusters. So let me show you. If I click into the Loyalty Workspace, I come to a namespaces screen. And it shows me that I've got a loyalty namespace on all three of these clusters. Those three namespaces, they're all named the same thing, but they're on three different clusters, are all part of the same workspace. And then if I click on workloads, I'll then be able to see any of the workloads that are deployed into those namespaces across any of those clusters. Now, this is a good way for you to segment resources for, say, a development team. In this case, maybe I've got a loyalty development team that needs to be able to see the resources on all of the clusters in the environment in one place. And maybe I've got another team that's responsible for like a shopping cart app or something, and they're also using the same clusters. They don't want to see the loyalty stuff, or maybe they shouldn't see the loyalty stuff. You can create a different dashboard for them so that they can see their own workloads, right? But this is a way for you to organize things for development teams so that they can log in and get details about some of these resources. You can get YAML information, you can get CPU and memory information about what's going on. There's a lot of good information here that you can get at a quick glance across clusters. Now back to the policies. I wanted to mention that TMC is going to allow us not only to do cluster lifecycle of our Tanzu Kubernetes clusters, but it'll also let us do policy enforcement. So it's sometimes really difficult to keep configurations the same or at least similar on multiple different objects. So if we've deployed these three different Kubernetes clusters, we might have to create role-based access controls for those. We might have to create admission control rules. We might be creating security policy rules. We might be creating network policy rules. We could be creating quotas. There's a lot of things that we might want to be configuring on our Kubernetes clusters. TMC is going to allow us to create policies in one place and enforce those policies down to either a cluster group, or a workspace or a namespace. So it kind of depends on what kind of a policy it is, but some things are cluster scoped, and you can apply those to either a cluster or cluster group. And some policies are either namespace or workspace scoped. So that's how you would apply those. Now, you can apply any of the policies here that you want, or you can create your own custom policies and associate those. As a quick example, I went in and created an image registry policy. And those are set at workspace level. So if I went into my loyalty workspace here, and you can see I've got three namespaces, I have a harbor only image registry policy created. And if we went and looked at that, you can see that my rule says that if I'm going to be using an image registry, it has to be named harbor.hardtophotels.com. If it's not harbor.hardtophotels.com, it's going to block us from actually downloading any images from that repo. If you're wondering why you might do something like this, this is a very common one. A lot of times you've got a process in place to build your containers and secure your containers so that you know there's no vulnerabilities in them, or they've been scanned properly, they've been built by the right people, and then they're typically stored in an image registry that you control. This one would prevent someone from going out and pulling a public image from, say, like Docker Hub or something, and using it in your clusters where maybe you don't know what's in that container image. So this is a common rule that gets applied, And it would be applied in this case across all of the namespaces in our workspace. So in these 3 clusters, in the namespace loyalty, they can only pull images from harbor.hardtaphotels.com. And this sort of methodology works for other things like network policies to prevent access from one container talking to another container, or a security policy, which is preventing a container escape or getting root credentials on the node where the container runs. You can build these policies and apply them uniformly, not only to Tanzu Kubernetes clusters, but any conformant Kubernetes cluster, which would include things like Amazon EKS or Azure AKS, right? So you can assign those policies to those if you attach those clusters here. And I think that's probably about as much time as we've got for a demo. And we're probably looking to get some Q&A started at this point.
All right. That was a good demo. Thanks, Eric. I think we have some questions here in the chat window that we could answer live. So let me ask this first one. What kind of network access do I need for Tanzu Mission Control?
Yeah, that's a good question. So your Kubernetes clusters are going to actually reach out to Tanzu Mission Control to get jobs to do or to assign policies and things like that. So the way that works is Tanzu Mission Control gives you basically a YAML manifest that you can apply to your Kubernetes clusters. That deploys some pods into your Kubernetes cluster, and then those pods reach out to Tanzu Mission Control as a SaaS service, and then get the work that they need to do inside the cluster. So you'll need outbound internet access in some way to get to Tanzu Mission Control at the moment, and you can use a proxy if you're locking down your internet. So you can proxy out to Tanzu Mission Control to get those jobs. Good question.
Thank you so much. And obviously we're gonna improve these things going forward. So where do you get the operating system image templates for Tanzu Kubernetes clusters? Another good question.
Sure. Yeah, so when you go out to the VMware downloads page to download the Tanzu Mission Control CLI, and that CLI is what we use to stand up the management cluster and then deploy workload clusters afterwards. Once you do that, there's also links there on the downloads page that show you your options for downloading an OVA template. You've got a couple options at the moment. You can either download Photon OVA template, or you can download Ubuntu OVA templates. Just deploy those OVAs into your vSphere environment, wherever you're going to be deploying those. And then once those are available as a template, when you run your TKG installer stuff, you'll be able to select those from the dropdown and then use those. And those will be updated every time there's a new version of Kubernetes or there's patches that need to be applied to the operating system. You'll see new versions of those become available. You would put those in your vSphere environment. Great
Thank
question.
you, Eric. Yeah, appreciate it. I don't see any other questions, so we could close, but certainly feel free to reach both Eric and I for any additional questions. And I would highly recommend that you guys register for VMworld. That's around the corner, right? And we're gonna have a ton of other innovation to announce, potentially to make this solution really easy to consume, not only for the DevOps personas that we focused on today, but also our IT admins. So stay tuned for those. Thanks for doing this with me, Eric.
Yeah, thanks for having me. This was awesome.